of steel beam design. In this video, we'll quickly go through shear capacity of the beams and high shear and low shear case. So let's get started. If you come to page number 59 of IS 800, there you will find section 8.4, which is dedicated to finding the shear force, shear capacity in beams. Clause number 8.4.1 refers to such formula where nominal plastic shear resistance under pure shear is given as AV FYW divided by root 3. Right, so you can use this formula to find out the shear capacity of your uh, beam. Now coming to the high shear and low shear case, usually in case of beam there are two main loads that are acting, right? Shear force and bending moment. Okay, now when there is the shear force is quite small or maybe up to certain limit, that is in this case IS 800 is stipulated as 0.6 VD, VD being the shear capacity here, right? So if your external shear is less than 0.6 VD, in that case they have said that it's a low shear case, right? Low shear case means the in that particular case the shear force does not affect the moment carrying capacity of the beam. So if I go back to the right here, if I come back here to the moment carrying capacity formula, here it is stipulated that when the factor design for shear force does not exceed 0.6 VD, where VD is the design shear strength of the cross section. So if this is the case, in that case it's a low shear case. Here the shear force does not interact with the bending moment capacity of the beam. So the bending moment capacity will be found out using this formula simply. But if the shear force, the factored shear force is more than 0.6 VD, in that case it is considered as high shear case. Okay, so if it's a high shear case, that means that the high amount of shear basically is affecting my moment carrying capacity in the beam. It starts interfering with the moment carrying capacity of the beam. So my moment carrying capacity of the beam is somewhat reduced in that case. So how can we find that? So let's see here, design bending strength under high shear as defined in 9.2. So section 9.2 deals with high shear case. Let's go to section 9.2. We're still at 8. Okay, we overshot it. Right here, 9.2, combined shear and bending. So here shear and bending has been combined into to calculate the bending moment using this formula, right? So here you can see for plastic and compact section the formula is given here. MD is the design strength, strength that has been we have calculated before. If it's a low shear case, then what will be the value of moment that we have calculated, and this is the deduction. This is the deduction which is required for high shear case, right? So simply applying this formula, you can see here beta is given as 2V by VD. V is the factored applied shear force governed by wave building, and VD is design shear strength as governed by wave building, right? So this is the applied shear force and this is the capacity of the section. So you can easily calculate the moment capacity in case of high shear case using this formula. And again this cross check will need to be there because obviously you don't want yielding to happen in working load conditions, right? So and also there is for semi compact section and another formula is given there, right? So this is all about shear capacity of the section and high shear and low shear case. In the next video, we'll try to address the topics such as web buckling, web crippling, and what are the deflection criteria in case of steel beam design.